All right, good morning. My name is Roshan, and thank you for having me here this morning. I run a company called Mindstix Labs. We're a digital innovation company primarily working in areas like industrial IoT, mobility, and cloud transformation for our customers. What I'm going to talk about today is how Apex has enabled manufacturing process traceability. So we work with quite a few industrial customers where on the shop floor they would like to create visibility in terms of the activities and events that are happening. So my talk has three parts to it. We'll talk about why you need traceability, what's the need and demand in the industry for something like this. The second is how do we enable it actually on the shop floor in terms of what kind of devices do we deploy to make this happen. And the third is how Apex plays a role in delivering this solution. Let's start by looking at news from the last 15 days in the automobile segment. Toyota announced a recall of close to 2.9 million vehicles for faulty airbag inflators. And again, the source was that the vendor that they sourced this from, Takata, has actually had much worse problems. They've recalled close to 100 million airbags, which are already out there, deployed in the field. And the list goes on. Ford has, just a few days ago, again, Ford has a recall of close to 500,000 vehicles for potential fire risks. If you look at the pattern of recalls over the years, and the NHTSA, the Transportation Safety Board, has actually claimed that over the last 20 years, the number of these recalls have been consistently increasing. What used to be typically 70 or 80 recalls in a given year has now actually jumped to about 180 different recall incidences in any given year, right here in North America. Does that mean that companies are actually doing poorly in terms of product reliability? Does it mean they're becoming sloppier at what they do? Well, not quite. I think what has happened is consumers are more aware of their rights. There are stronger consumer protection laws today. Yes, manufacturing defects do attribute to the root causes of it, but vehicles also have better telemetry today. So because of that, establishing root causes, emerging patterns from what has happened out there in the field has become much more easier. Sometimes companies initiate voluntary recalls because they have perceived risks associated with those recalls. And most importantly, today we are living in a sort of a manufacturing process where you source things on a global scale. What is essentially needed is to be able to pin the responsibility for those defects. And you cannot pin them down to an entire product line. You need to narrow this down further. So recalls, just in the automobile segment, have been extremely expensive. Close to about $40 billion a year is what the industry spends on recalls and warranties. And there's several aspects to this cost, right? You're talking about the reverse logistics of having to acquire the product back from the market. You're talking about the cost of the repairs, the cost of safe disposal of those items, the cost of compensating customers, and of course, loss to the brand credibility and the loss of sale that's triggered because of that. And this is not unique to just the automobile segment. If you look at some of the other segments, last year, again, unfortunately, Samsung had this big, much publicized recall of the Galaxy Note 7 devices. Mattel actually pulled out close to 20 million units of toys because of alleged higher concentration of lead in the paint used in those toys. So what is really needed here is, from our point of view, is three things. You need to establish a clear traceability of every batch that gets shipped from the production line. And you need to establish a lineage for that batch, right? So you're saying that my given product has close to, say, about 300 to 500 components in my bill of material. Each of those components are sourced from multiple vendors, multiple suppliers, over a period of time. So when a batch goes out of the shop floor, I need to be able to establish, I need to be able to pin the liability of a defect to a particular batch that I have sourced from my vendor, so that I can contractually then shift my financial liability of the recall to my suppliers. The other important aspect is what we call as narrowcasting the effect of a recall. So do I really need to pull out the entire lineup of products from the market? Do I need to pull out specific products? Or do I need to pull out only a much narrower batch of the products? And you would not be able to make these decisions unless you have traceability on the shop floor for these kind of decisions. The other area around traceability is you need to track the production variables, the real-time production variables from the shop floor when that batch was manufactured. So this includes things like what kind of tools were used, how were those tools calibrated, which personnel were deployed as part of manufacturing that batch, and of course what raw material and inputs have gone into making of that batch of products. Now, in many cases, this need for traceability is also driven by vendor compliance requirements. So let's say if you are a defense contractor or you are a supplier in the aviation industry, unless you have the traceability at the BOM level, unless you have traceability at the level of production variables, you will not even qualify to be a vendor to supply to certain customers. And we extend this thought to something else, which is the ability to generate alerts on the shop floor in real time. So there are a lot of near misses that happen on the shop floor. There are a lot of misconfigurations of tools, a misconfiguration of feeder lines that happen on the shop floor. So we are trying to see if Apex-based rule engine can aid in detecting these anomalies. So every product has a certain blueprint based on which it gets manufactured. And every production line has a bunch of feeders which feed the raw materials. And very often we've seen a common problem. A 2 mm screw gets replaced with something of a slightly different calibration. So those are the kind of areas we also want to catch on the shop floor as part of real-time stream processing. So one of the customers we work with manufactures instrument panels for automobiles. And a typical unit like this consists of, the final assembly actually consists of close to about 250 to 300 items in its BOM, the bill of material of that product. And then you expand that further. So if you look at something like an electronic module, which is part of this instrument panel, you expand that further and you see there is a printed circuit board, there is a surface mount chip, and so on. Right? So the goal is, can we, for any given batch of products, actually establish the genealogy of every item that constituted that manufactured product? So we start off by, when we acquire the consignments, we actually go through some kind of a random sampling and testing process, the vendor quality assurance. Some of the materials is supposed to be directly fed into the production lines eventually. But what we essentially start by doing is kitting these raw materials into bins and having RFID tags on those bins. So before these bins can be fed into the production line, you already know what SKUs, what consignments they were obtained from, which supplier you sourced them from. And then in the manufacturing process itself, when you look at each of these feeder bins, these are the same bins that we saw on the previous stage. You have people, processes, and tools involved at each stage of production. The employees on the shop floor are actually given variables which include an RFID tag, so you actually know who were the employees in the proximity of that particular production line. So the company we are deploying this at has close to about 80 production lines. They have plans to scale it to about 120 over the course of next 2 years. You also want to know what assets were used at every stage. So you're talking about Also information like when was this tool last serviced? How many units have we produced using a given tool? So a combination of sensors which capture this information, also sensors which capture ambient environmental conditions. For example, what's the humidity, the microclimatic conditions. Humidity, for example, causes dry soldering problems in if you have an assembly line making electronic modules. So the idea is to gather all this raw telemetry information as well as to gather all this raw material and assets information from the shop floor, which is what we see on the left here. Information about ingress queues, egress queues, ambient parameters, deployed personnel, the configuration information about the tools, and to be able to generate certain real-time insights. To give you a few cases here, you need to make sure the right personnel are deployed on the right assembly lines. And sometimes line supervisors tend to, because they have to deal with people taking time off and things like that, they tend to reallocate people, but sometimes they tend to reallocate the wrong people on the shop floor. The other example is if a batch that was sourced from a supplier is deployed on multiple production lines, and you would soon realize in the QC process later that this batch is defective. The sourcing component you got is defective, but the component is already there on a bunch of production lines. So you declare this component to be quarantined. You declare this batch to be quarantined, but you need to generate some real-time alerts if that component does get embedded as part of an output product. So FIFO violations is the other example where there's an expectation to utilize the raw material in the same sequence in which it was acquired from your sourcing vendor, but sometimes it does not get picked up in that way. So the system can actually generate real-time alerts if there are FIFO violations as well. These are real-time, and then the other area is we are writing this information about product lineage to HDFS, the idea being that you need to retain this information for at least the lifetime of these products. In the case of automobiles, which is anywhere between 24 to 36 months, and now more so between 50 to 60 months out there in the market. And since we are talking about batch level information, we are talking about literally hundreds of SKUs being manufactured on the shop floor. There is quite a bit of information that gets aggregated over a period of time. I think our choice of Apex here was influenced by the fact that we have a large number of unordered events that come out from the shop floor. We need to ensure that there is reliability of this event delivery and processing, that they are not dropped. There's no best effort kind of approach, but there's a guarantee that certain events are not dropped. And I think our fundamental use case is to be able to group these events on a windowed manner based on event time, to associate these events with a certain production batch in the assembly line. And large-scale persistence is something I already talked about. Since these are companies who don't necessarily, they're not necessarily experts in running data centers and data farms. These are often deployments closer to the shop floor itself. We're looking at something which is operationally also very predictable. It is able to handle typical failures of components on the rack deployments. So I think these were primarily the drivers of why we wanted to use Apex. And I move on to my last slide. I think this is the one where it's a simplified flow of how we think of it as a DAG, that this eventually got translated to a DAG. We are getting most of the parametric values from sensors on the shop floor over MQTT. Sometimes RFID tags do trigger multiple times. If you move the bin, for example, closer or a little further away, the tags trigger multiple times, so you need to dedupe them. We enrich the data about coming out from the bins by associating the sourcing information with it. And then we are doing an aggregation based on event time here for those events. Um, and some dashboards. So for example, SKU incompatibility. If we detect that a blueprint of a product on a certain production line is expected to utilize 20 SKUs, 20 specific SKUs, but somebody accidentally put a different bin on the production line. Now the line worker may not realize this because the variances in the components may be minor, but those things can be caught and alerted as well. So where we are today in terms of this deployment is there's some early stage field trials. We are going to go live soon with a couple of production lines to begin with, and hopefully, to Amol's point earlier in the morning, we are not in the 70%, but in the other 30% of big data initiatives and deployments. So thank you for hearing me out, and happy to take some questions.
Actually, I just wanted to know, like, all you describe over here, it needs a lot of sensors on your workflow or in your entire line. So at least as I know, like, there is not that maturity in production lines till now. So is it, I mean, how difficult it is for you to capture all this data, and because you need to capture all this data, and it's not that mature yet. That's what I feel.
So there was a point in time when traceability was a nice to have. I think it's come to a point where this customer of ours said, I am losing orders from our potential customers because we do not have traceability in place. And what they ended up doing was a very pen and paper based system. You have line supervisors running around. You have them tagging post-its on individual bins and so on, which is then causing a lot of interference with their motion studies as they are trying to optimize the hops that happen in the line. So I agree that there is a substantial investment, at least in terms of some of the infrastructure they have to enable on the shop floor. For example, they did not have wireless connectivity on the shop floor. But at the same time, if you look at the price points for RFID tags and sensors, and the price points for some of the IoT gateways where we are aggregating this information, those have been dropping as well. So I think it's become a forcing function for some of the companies, given the costs of recalls, that they invest in something like this. So, yeah.
And you know, there are multiple. Sorry. So my question is actually, there's a complex manufacturing lines, right? So do you replicate the design of shop floor on the cloud, and how do you model those assets, if you will? And is your solution running closer to the edge, or is it running on the cloud and stuff?
Okay.
But there are safety critical action items, right, that you might need to take closer to the machines.
Yes. So the gathering aggregation of data from the sensors, particularly in our case the RFID readers, is done closer to the edge. We have IoT gateways deployed, like the Dell Edge Gateway, which is ensuring that heartbeats and things like that, the sensors are not going offline, or if network connectivity intermittently drops, the gateways are locally caching this information and eventually dispatching it to the cloud. Now, the early trials we are doing are not on-prem. We are actually using a cloud-based deployment. But it's very likely that as they scale up, they would want something that's much closer on-prem. Now, to your point, this also does not block the production process. It rather helps us identify the gaps. So if you had a certain product that needed 200 SKUs, and you realize that you did not eventually capture sourcing information about 3 of those SKUs, that's valuable information that you don't get through a pen and paper-based system today. We have to model production lines. So usually there is a 3-stage process. There's a sub-assembly process, there's a final assembly process, and then there is a QC and a curation process. So we do have to model assembly lines. The good thing, though, is because you can change your rules, you can update the DAG on the fly. I think they're taking an approach where you're starting to collect a lot of raw data, starting with some basic analytics, basic insights, and then improvising it as you go along. So, thank you. Yeah, sure.
Could you add some more color into the level of integration with the actual assembly line? I'm trying to understand if the system you put together is mostly for informational and alerting purposes, or can it be used to actually control the assembly line based on what this system discovers?
Okay, great question. So the two parts to it. At the moment, the system does not integrate with. So some of the assembly line machines are controlled through SCADA. We have not integrated with that yet. The intent here was not necessarily to have an automated feedback loop where the machines can be controlled as well. The intent rather was to alert the human in the loop. Right? So there are line supervisors who sometimes lack visibility of what's happening in the shop floor. They do not know that a quarantined batch was deployed and is being used to make items on the shop floor. Those are the kind of errors and near misses that we are trying to flag, and not necessarily being able to automatically control machines, at least not yet. Yeah.
So we'll have a 5-minute break before we start again for the next session. Okay. Thanks a lot. It was a really informative session.
Thanks.
Yeah, thanks.